Greatly restricted by the technology of our time, whole brain emulation is still very much in its infancy stages. But it's gaining acknowledgement in medical and academic circles all around the world. Dr. Randall Cohen believes that we are rapidly advancing in technology at a fast enough pace that WBE will be possible within the next 100 years. In 2008, Anders Sandberg and Nick Bostrom published a white paper with the Future of Humanity Institute called A Whole Brain Emulation, a Roadmap. In this paper, they detailed 3 steps in the process to whole brain emulation. One is be able to take high enough resolution brain scans that they were so detailed that the systems and subsystems of the brain are easily distinguished and interpretable. 2 would be to build and create a software that can interpret these high-resolution brain scans. 3 would be to simulate a model of the data that so accurately emulated the human brain that it could not be told apart. Now, they also commented in the paper and said that they believed that the technology would exist for WBE before the middle of the 21st century. So through these steps, WBE is theoretically achievable. But as is the case with much cutting-edge research, the technology needed to apply and test these theories simply does not exist yet. But Dr. Randall Cohen, commenting on the technologies, Dr. Randall Cohen is a head of Carbon Copies. It is a workshop and research think tank that focuses on WBE research in the field of. Dr. Randall Cohen is quoted saying, "I would be astonished if scientists emulated a mouse brain, which only has 71 million neurons, within the next 20 years. But I would be as equally astonished if we failed to emulate the human brain within the next 100 years. The human brain has around 86 billion neurons in it." So you might be asking what technology is needed to emulate the human brain and the neural networks involved in the human brain. It comes down to the lack of extremely powerful and fast supercomputers, fast enough to process and translate these brain scans. Then these processes will most likely need to be carried out by quantum computers, which are also very much in their infancy stages. But other technologies are growing and furthering in their research in this irreverently complex field, such as the company Neuralink's flexible brain threads. Now, these brain threads connect synapses and neurons to an outside computer, and they allow simple commands to be made, and they allow the computer to interpret outside stimulus through a neurological pattern. Now, this is all relevant to the neuroscience and the theory of WBE. Now, some of the questions you may ask yourself are possibly, what are the benefits? What will we be able to achieve with whole brain emulation? Speaking from a neurological standpoint, the options are almost limitless. From things like repairing and correcting damaged brain systems using emulation, or preventing further deterioration from diseases like Alzheimer's, or preventing neurological diseases altogether like narcolepsy, or preventing the brain to continue to harm itself through different neurological process. All of these will be possible through whole brain emulation. Now, outside of the neurological standpoint, the applications are still extremely expansive. For instance, whole brain emulation will allow us to pilot a robotic version of yourself or truly experience virtual reality for the first time. Truly, the possibilities of whole brain emulation are endless.